Hi, everybody. Welcome to second session of Scalus Club. We are happy to see many people joining for second time. Today we have a special guest as well, Hydrozoa team, who will be presenting some of the cool stuff that they're doing with Transaction Builder, but also in testing of the protocol that they are developing. Quick recall about Scalus. So Scalus is a full stack development platform where you have everything built on Cardano. During previous session, we were presenting how to build smart contracts with Scalus. Today, we'll be speaking about Transaction Builder and how to test transactions and how to use transactions or sequence of transactions to test your smart contract or your protocol or decentralized application. The session is structured in a way that we have a couple of topics in it. So today we're speaking about building transactions with Scalus. We'll start with a quick introduction of this module. So Alex will present us the general idea behind Transaction Builder architecture and how it's structured. Then Ilya and Sergey will show us how actually build a transaction in the code using the middle layer and high-level API. Then we'll see how we are validating transaction locally and on the testnet. And then Hydrozoa team will be presenting the advanced use of Transaction Builder and testing scenarios. The session is organized in a way that we are showing our work in progress. And the main goal is to share with you how we think about developing Scalus and resolving real world problems. And what we're looking for is an active exchange and discussion, and we're hoping to receive some feedback, maybe ideas, maybe some use cases that are not covered, so that we can, while developing those components, we can incorporate those feedbacks and actually build it in a way that it answers those needs and challenges. And it will be heavily in code, so don't worry. We will jump in the code very quickly so that you can see how things are working, and then we can follow and discuss. Every session would be structured in a way that we are presenting for 10-15 minutes one of the topics to start and generate the conversation. The demonstration of capabilities will be delivered in one block. So if you have questions, please use the Q&A module to post your questions. And after the demonstration, we'll have 15 to 20 minutes, 10 to 15 minutes, depending on the session to discuss. I think that's it. Before we start, do you have any questions? No, let it go. I will give the microphone to Alex to speak about transaction building with Scalus.
Yeah, hi guys. Briefly on the transaction building cycle. So I think mostly technical people here, so you probably are familiar with this life cycle. So usually what we start is we're querying some UTXOs. Either we are trying to spend some locked funds or implement some protocol steps, or we just want to do a simple Alice to Bob based transactions, and we need some inputs from our wallet and ways to pay fees or add the collateral. Then we build the actual transaction using those inputs and outputs, add scripts, all that stuff, and then we need to evaluate scripts to compute costs, execution budgets. This is the way for us to calculate fees, and then we need to balance this thing out. And this is actually a cycle. We can go through it multiple times, because as long as you change fees, you might change the size of transactions. That might change the fees again. Then you need to take more fees from inputs, give the rest to the change output, and do it until it reaches a fixed point. After that, you can sign your transaction with the real signatures, and submit. That's the life cycle. And we approach this essentially by splitting the transaction builder in essentially 3 levels. So we have the Cardano ledger types implemented. So you can just take the transaction class, or redeemer, or transaction input, transaction output, and construct the whole transactions by yourself manually. That's the lowest possible level. So you can actually do this from scratch, but that's inconvenient. Well, you might sometimes you need like your specific transactions. You need exactly like that. You need a full control. If you need this, you can do this. You can construct the full transaction on your own. And we have this low level, it's like system level API. It's essentially a bunch of helper functions that allow you to do this final fee calculation and final balancing step, just for convenience. And this is this level, domain objects plus this final fee calculation plus script evaluation steps. This is a foundation for a higher level API, which was developed actually by Hydrozoa team. They will present it with more details later. But this is, like, in a very nutshell, is sort of kind of a set of intentions that you would like your transaction to follow, and an interpreter that converts those intention into a transaction that actually then uses this lower level API to balance the transaction. And on top of that, we've developed the high level sort of a facade API, or DSL kind of style API, which is closer to what Lucid Evolution may look. Kian? Sorry. Kian, you're not muted.
Oh, sorry about
yes,
that.
Yes, no worries. So this higher level API allows you to construct very simply a subset of very useful, commonly useful transactions. And this API actually uses the middle level API. So yeah, that's the basic idea.
Yeah. So I think it's not news for you. We just wanted to show you a couple of insights about how our transaction builder is structured and why it's structured this way. To follow, I'll give a mic to Ilya, who will help us with the deep dive into transaction builder building with the middle level API. So feel free to grab the presentation.
Yeah, thanks everyone. Let me share my screen. And I'm going to show you how that middle level transaction builder is working using very simple examples. Can you see my screen?
Yes.
Good. Okay, so as Alex mentioned, we approach transaction building, splitting it up into different phases. And the idea is that only the first phase is kind of IO bound phase, when we do actual requests to network, finding out our transaction inputs and spend transaction outputs and stuff like that. And all the subsequent phase are, so to say, pure. We don't need any additional information to complete that stuff. Probably the signing is an exception, but the transaction building, the middle level transaction building, is focused on the building the transaction itself. So first of all, to do that, we are using a context, a built-in context, because the transaction type itself doesn't contain enough information to make the building, so to say, safe, right? You can, for example, you can add a collateral input, thus specifying UTXO ID, and you don't have any ideas. Does it contain any tokens, where it's locked, and stuff like that? And that context keeps track of some important information that simplifies the building process. On the other hand, using that transaction builder, you can build absolutely any transaction you want. So you maybe do need more steps to get the same result you can do using the low-level builder, but in principle, you can build any transaction. So the entry point is that build function that takes the network and the list of steps. And here we can try to run it on the empty list to see the empty transaction it can build. The network here is needed because the transaction builder checks that all addresses belong to the network specified. If you try to provide another address, it will be an error. So here we see the CBOR diagnostic notation for that transaction. It's an empty transaction. And we see some part of the context, which is kind of important for us. This is the expected signers, and it demonstrates how Builder can help you with building transactions. So let's move on. As I mentioned, the first phase is resolving when we get all our UTXOs. And for test purposes, we are going to use that genUTXOs function that just leverages the pretty big set of arbitrary and generators instances we have in the Scalus library called testkit that simplifies testing. You can generate addresses, UTXOs, whatever you want. Here, particularly, we generate 2 UTXOs, and the additional UTXOs that is logged at the same address as the first UTXO here. So we have 3 UTXOs logged at 2 addresses. And now we can build the transaction. So we already kind of have inputs, and all we need is to provide an output to complete it. Here I can show you how we can use Scalus domain types to build some values. So here we have address and the value. For address, we can generate pub key.
Gen, not get.
Yes, thank you. Gen pub key. Gen pub key address, and for value, we do need some value, and in our case, let's just combine together what we have in our inputs, right? So for now, the only way to do that is to combine values, is to use some operators Scalus provides. There are no currently aggregations, but probably George can briefly mention an upcoming PR we prepared for coin and value arithmetic here. So for now, I'm just going to use fold left.
Yeah, we'll probably present that in a future session. It's pretty
okay.
Cool.
Yeah, and here, yes, we need to do accumulator and output, and we need to combine them together. So it's output value, I believe, something like that. And let's start to run it, providing 2 steps for the builder this time. So we are mapping our inputs into the spanned steps, specifying that those outputs are locked at the pub key address. There are different types of witnesses, and the way the builder learns about different UTXOs is by taking those steps. So if you spend an output that is locked at the Pluto script, you can use 3-argument Pluto script witness, where you specify the script source by providing the script itself or specifying a reference UTXO, the redeemer datum, and additional signers that this particular script might require. So in our case, we are using pub key witness, which means that it's an ordinary UTXO. So let me try to run this test, and hopefully we will see a transaction with some content. Three inputs, 1 output. And if we take a look at the content of the expected signers, we can see that the builder automatically determined that there are only 2 keys should sign that transaction. Okay, so what if we have a transaction and later on we need to add something to it? This is also can be done using the transaction builder. The way we do it is that is using modify function that takes a non-empty context and a list of additional steps that we want to do. And for example, imagine that we at that stage 2 we finally get the fee UTXO that should be used for paying the fees. So here we can add a list of additional steps. The first will be spent that fee UTXO using pub key witness, and the next will be sending that UTXO back, which is expressed by fee UTXO, sorry, fee UTXO output. The important thing here is that the context itself doesn't preserve the steps from the previous stage. So you can only add new steps on top of what you had before. Arguably, this is not an ideal implementation, and we are considering changing that in the future. But now this is what we have. So we added more input and 1 more input and 1 more output, and now we can use that output to balance the transaction. Now there are 3 signers here in the list because we added an additional UTXO that is at the different address. So the balancing is done using a special handler that's called change output diff handler, and you can implement your own implementations, but the default one allow the user to specify a change output index that will be used to cover fees. And in our case, we're going to use that second output as the change output. And also this method is defined as an extension method on the building context, and it requires protocol parameters and test evaluator for evaluating scripts in the case they're present. So the balancing step will give us a transaction with fees calculated and with the proper change output. So here we can see that fees are here. And finally, the last phase is validation. And here we can use the fact that Scalus has all validators that are defined in the ledger. Probably not all validators are fully implemented right now. Alex can correct me here, but we have almost all validators. And the nice thing here, yeah.
We implemented, all the ledger rules that work with UTXOs and scripts. The only thing missing is stake. Updates to stake distribution.
Yeah. Okay, makes sense. Right. So here I have a list of validators that Hydrozoa uses for validating unsigned transactions. So some validators are missing here, and but the nice thing that you can easily change that, right? So it's more it's just a matter of adding a missing validator to the list. And if we add, for example, missing the hash validator to that list, we will see an error because the transaction isn't signed. Otherwise, we can pick only those validators that are really needed for that particular use case. For example, in Hydrozoa, we use transaction size validator to determine whether a transaction we are trying to build by adding more and more inputs or outputs still fits the ledger limits. So that's basically it. All phases from the resolving, building, optional, additional steps, and balancing and validation we've seen. And yep, that's it. Thank you.
Yeah, let me just jump in there to give. So overall, what does this transaction builder achieve? So first of all, it allows you to decompose the transaction building into these sort of self-contained steps, or as Alex had called them, intentions, right? And in each step, you can kind of specify what you want to do without referring to any indices within the transaction. So like redeemer indices, or output indices and things like that, because that's all fragile, right? Like if something changes in the transaction, something gets reordered, all of a sudden all those indices have to be fixed up, right? Whereas if you just have these individual steps and you let the transaction builder handle the wiring of them using the indices, because Cardano transactions, when they're serialized, they like to use indices all over the place, right? But when you're building, you don't really want to use indices because, as I mentioned, they kind of break. Right, so we allow you to abstract away from that and just say that, hey, I want to, introduce this redeemer, and I want to, it allows you to refer to things in a more logical way. The other thing it does is it collects the all the signatories that you need for all your inputs, right? So that's something that Ilya said. So, for example, if you're spending from a simple, single pub key address, it's going to automatically catch on to that, and it's going to say, all right, so we're going to need that person to sign off this transaction. If you're signing from a multi-sig address, like a native script or something, right? There's a little bit of ambiguity, because in general, native scripts can be satisfied by, a huge number of different combinations of signatures, right? You could have a native script that says that either M of N of these people signs, or K of P of these people sign, or so on, right? So when you say that I want to spend an input from a native script address, the transaction builder also asks you to specify how exactly are you intending to satisfy the conditions of that native script, right? Which specific signatories are going to be satisfying the conditions of it, right? Similarly, for PlutoScripts, you're going to say, all right, this is the PlutoScript witness that I want to use. This is the redeemer that I'm going to use to satisfy the conditions of the PlutoScript in question, right? And so the context keeps track of all of this, and then is able to, at the very end, when you want to, build the transaction out of all these steps, is going to construct them, the transaction, and then you can balance it and submit it. But at the same time, we also recognize that sometimes you don't know the full sequence of steps that you need to do. Right? Sometimes you need to have a partial result of like, this is a transaction that's almost there, but it's missing a few pieces because we still need to add a few steps, right? And you're going to see this in our example later on when I talk about Hydrozoa, where in some cases, yes, we need to build a transaction part of the way through, and then we need to take some partial result of it, pass it on to some other transaction that's being built, and then from the partial result of the second transaction, bring something back to the first one, finish building this one, and then pass that back to the second transaction, because they're kind of dependent on one another. It's a very tricky thing, right? So the modify method in the builder allows you to do that, right? It allows you to pick up in the building process of a transaction by adding a few more steps, right? So that's kind of the general idea. And we've sort of tested this transaction builder flow in practice with a fairly sophisticated real world example. And you know what? It's been meeting our needs. We haven't really had to make many modifications to the transaction builder that we came up with and contribute to Scalus, a month or two ago or whenever it was. So I think it's holding up pretty well so far in a real world use case.
Okay, thank you. I'll let Sergey take over to present the high-level API and like our first steps in building this DSL layer. And after that, we can discuss if you have any questions.
Thank you, George. Thank you, Ilya. So, like the guys mentioned, the transaction builder consists sort of several layers of abstractions. With we're in what is colloquially known as a low-level transaction builder. Allows you to, with limited comfort, however, with fine-grained control to create a transaction just the way you want it. The steps, aka intentions, allow you to, create transactions with control, but abstract away all of the annoying parts about building it. And moving up another layer of abstraction, we intend to have what will be known as a high-level API. And what you can expect from it is, whatever you go out and Google, like whichever transaction builder, right? You're going to be hit with simple examples of, payments to addresses, of perhaps spending one script logic, so perhaps minting something using, whatever script that you might want to use. Not really like protocol level transactions. You're going to be looking at like 5 lines of nice simple code, and this is what we're aiming at with the high-level API. Currently, we do payments, which I'll actually show you on this screen. So what you're looking at is a file that contains transactions related to our old friend HTLC validator, right? A simple but complete validator that allows you to spend inputs as long as you provide a valid preimage. And near it, using the transaction building described above, we can create transactions which you might find useful when interacting with this contract, when testing it, whatever. You can lock the funds in it. You can try to reveal it as long as you have a valid preimage, or you can time out if you're the owner of the DUTXO and a valid preimage has not been provided, during the timeout expected. And here you can see the high-level API. It allows you to drop into the middle-level API with steps, which is quite a useful thing. However, if we remove these ones, you really see like the simplest thing. You pay to some address using some values. You provide some inputs that you already have as collateral, and blah blah blah. But it allows you to drop into the middle-level API and fix whatever things that you might want to fix. So with that out of the way, when you're done implementing your transactions, it's time for you to test them, right? Test the transactions, test the validator using the transactions, and kind of send them somewhere, because they're kind of useless without the ledger to send them to. And for testing, it's it's obviously very. I do not see your hand, so if you want to interrupt, I guess you should.
Yeah, I wanted to make a pause here to have a quick conversation about 2 layers of transaction builder. And I wanted to add only one thing to what Sergey just said, is that we see high-level API really as a DSL. So basically you define your intentions on the middle layer, and then you can define some kind of very simple API that you can use later on in your application. So you can really reason on 2 ways: in the moment when you build your intentions in your application, and then in the moment when you use a certain type of transactions. So to simplify the use, you can expose this DSL facade interface. I wanted to add this, and I think that's it. This work is still in progress. We started with the pay to and pay to address and script things. Later on, we'll expand it to other commonly used intentions. that you can find, for example, in Lucid Evolution or Cardano Client Lib. So our high-level API would grow into the area of covering majority of commonly used intentions. And for decentralized applications or protocols who would need a very specific way of transacting, they will have the middle layer API so that they can define their transactions. I want to open a quick conversation here. I don't see the questions in the Q&A, but I would put like 10 minutes for Q&A and discussion. So feel free to contribute. We'll start with Alex, and then let's see how the conversation goes.
Yeah, just I wanted to mention that there are several reasons, several design decisions we're keeping in mind. And the goal is, so the tracking of signatures allows us to correctly compute the size of transaction, and that allows us to do the exact fee computation, so we don't overestimate fees. Because, for example, in CCL, you sometimes need to add how many signers are you expecting to compute the size of transactions. With our transaction builder, it's tracked. In all cases, right? We have in all the cases.
Yeah,
right.
That's an invariant, right? So we built the transaction builder specifically so that the way the steps are specified, you always know what the consequence is on the expected signer set given that step, right? So if you're using the steps, you're not going even lower level than that, then that invariance should hold. And at the end, you'll just get a very nice set of, these are the expected signatories, which means during balancing, you can just add dummy signatures to, for the transaction size, and it all works out. So yeah.
Yeah, and another thing is this abstraction from redeemer certificates and other indexes allow us to have, and I believe we implemented it, allows us to actually separate redeemer production from its index. This allows us to use this providing the witnesses for protocols. So instead of looking for your own input in transaction, you can pass your own input as an index in a redeemer. So your script can then directly index the input. And not only this, you can index on outputs, on inputs, on certificates and stuff like that. So this makes it much more. So this is usually a like higher grain control needed by efficient protocols. So our transaction builder is built in this in mind, basically, and this we allow this, and we will try to construct our APIs so that we allow you to easily construct these complex and efficient transactions, and allow your protocols to use this witness passing essentially in your redeemers, which is, I don't believe many transaction builders do.
I have in the comments, I see the question from Matthew. Do you want to ask your question yourself, or let me read it for you?
Maybe I can.
Sure.
It was answered at the beginning. I'm not sure I was following exactly. I was wondering if those high-level intentions, pay to, etc., do they strictly like correspond to sets of with step transaction, like the middle level of yeah. Okay. See you.
Currently, yes. Yes.
Yeah, we have these intentions, commonly used intentions, and we just expose the DSL on top of it.
Okay.
I think that will remain true even in the future, right? Because if like the high level ones should always be building out of the middle level ones, or maybe sometimes the low level ones, but probably best to implement the higher level ones in terms of middle ones, because the middle ones, they ensure that the invariant holds of all the redeemers are properly populated, all the expected signers are properly populated. The low level ones don't. Right. So usually I think like the higher level ones should probably go through the middle ones just to make sure that the invariant is respected.
Yeah, and you can see it as a collection of intentions. So we have commonly used intentions like for governance, for voting, for I don't know, meeting and burning and stuff. So that would be provided, and then as we go, we can complete it with extra recipes and expose the DSL to them.
Can I ask, what is the output of transaction building? Is it just a transaction, or do you have other things?
No, you get the context.
Okay.
So the context includes the transaction, the list of so-called detached redeemers, the network, the expected signers, the set of resolved UTXOs, right?
Yeah.
So the redeemers, we call them detached because they're essentially, they don't have the indices of like redeemers and stuff, because that's convenient to do at the very end when you actually build a Cardano transaction, right? The expected signers is just the set of expected signers that we've collected from all the inputs so far, right? Deduplicated because it's a set, right? It needs to be a set. And then the resolved UTXOs, this comes essentially all of the spent inputs, all the reference inputs, all the collaterals, right? We collect them into a set of resolved UTXOs because we will need to pass this into the evaluator, right? When the scripts are evaluated, because scripts can only be evaluated with resolved inputs, right? Because that's Plutus needs all the inputs to be resolved, to be evaluated, right? So we gather all these up, every step. When it says that I want to spend a particular input, as Ilya mentioned before, you're not just specifying some UTXO ID, like some transaction hash and index out of the transaction. You're actually also providing the resolved output for that input. And this makes it convenient to gather all of these up into a set of resolved UTXOs and then passing it into the script evaluator when you're about to do balancing or something, right? When you need to see what the execution units are for CPU and memory so that you know what the fees should be and so on, right? And doing all of this in this way is convenient because it means that you can sort of separate the resolution phase, right? Of doing the Blockfrost calls or whatever to find out, what for the UTXOs that you're spending, what their outputs are, or even just finding them at a particular address and deciding which one you want to spend. You can separate that into a initial stage, right? Where you get all the information that you need to build a transaction. And then the actual transaction building is entirely pure. Right, it's much nicer this way.
So I will be showing how what is the result of transaction, how we submit it to different environments a bit later.
Yeah, one of the beauties of this is that by separating the step of finding the UTXOs, we can essentially have the same transaction building logic for different environments. So the way, we can abstract away the way how we get the UTXOs, either from Blockfrost or from test data or whatever, and then all the rest of the transaction building will be the same, and we will demonstrate it.
Yeah, it's great for the environment, and it's also great for the user experience because you can put that information for the context. You have the expectation of the signer, so you can give better interface for the users, if you want to track who has signed what and whatever. And also, if you have the resolved output, you can easily chain those things. So yeah, it's a good decision.
There was another question from Fabio about adding metadata. So there is on the middle layer is modify accelerate data, and we will have it. I think we already have it, and we'll add it.
Yes, we have it. We have it. Basically, we cover all the transactions, so you can.
I'm speaking about DSL.
About DSL.
Add metadata.
Okay.
I think it's either added already or it's in our backlog somewhere. It's very easy to add. So next step of building transaction builder is incoming, and we'll just expand all the DSL capabilities for high-level API to make it very convenient to use.
Currently, you just can do the with step and this modify auxiliary data step, and you'll have the metadata there.
Alex, one recommendation I have for you. I was looking at the payment builder, the high-level one, right?
Mm-hmm.
And your build function in it just returns a transaction. I would suggest returning the context because people might want to chain it, right? It might be useful to mix and match between the high level and the middle level, right? You could say that, hey, I don't want to specify, like, in terms of middle level steps, a bunch of stuff that is just very standard, right? I want to start from the payment builders, like context that is generated from that. And then I want to add in a few other steps to further customize it towards what I need, right? So
good idea.
Good idea. I would recommend always returning the context because out of the context, it's very easy to get the transaction, right? So.
Awesome, but Sergey, can we actually get the build context currently? Maybe there is another function for that.
I mean, the context
is
a superset of a transaction. Like every context has a transaction. So
yeah, the transaction is just a field in the context. And if you look at your build function or build method in the payment builder, at the very end, you have yield final CTX.transaction. You could just yield the final CTX. So that's my only recommendation. Because getting the transaction out is easy. Yeah. You don't want to lose information.
All right. So, I think we will wrap here. I'll let Sergey continue presenting about how we test transactions.
I'll actually use the privilege of my microphone to just add one last comment about it, because the goals of a transaction, there are several, but the main concerns are what kinds of transactions you can express, the total set of them, and how easy it is to do it. The middle layer handles the expressivity pretty well. There's I'm pretty sure Hydrozoa does pretty complex transactions, and all of those are covered. And in terms of ease of use and user ergonomics and DSLs and high-level stuff, Scala is actually a very good language to do that. And really, in terms of ease of use, the sky is your limit, right? If you're building a protocol where there's I don't know, where Alice means something, it's a word in in the vocabulary of your protocol, and then you can just do Alice to whatever, and all of those can be, Scala functions that do something and use the lower levels of transaction building to compose the exact transaction that you want. So there's really no ceiling for how DSL-y you want your thing to look. So
yeah, I think we will eventually show this approach in one of our next club sessions.
Yeah, how to build scenarios and how to.
Yeah, so it's going to be testing scenarios. It's going to be nice.
Yeah. However, let's get back to testing, right? So when we're done building our transaction using whatever APIs that we want to use, we want to test it, right? We want to, and testing transactions really means two things, right? Testing the validator at how it runs, because usually the kinds of transactions you want to use are, they spend script log UTXOs or whatever. And testing the transaction building itself. In terms of testing the validator, you can do it in several ways of increasing, of decreasing, I would say, level, right? The lowest level that you can do, as all validators are in essence functions from script context to either a unit or perhaps a Boolean, right? Whether we allow to perform something or no. Really, you can just use this. You can test this Scala function because this is Scala code, and be done with it. However, if you want to actually, do the transaction, assemble it, and then have it run somewhere, well, you have to run it somewhere. And for this, Scalus provides you with several options. The first one and the fastest one, and the one you're probably going to be using the most when actively developing whatever the thing is that you're developing, is do it locally against a Scalus. I would call it a ledger view. You can call it something else, but the gist of it is that there is a test in-memory provider. A provider is is definitely a very generic word. But the thing about what I'm showing you is that it's something that allows you to throw transactions in and see what happens. Currently, you cannot see much. You can only inspect the state, and you can use it to query the the unspent the UTXOs basically. Which is if you squint really hard, this is basically the Cardano ledger, or really any.
It's a sort of a node, kind of testing node, like something
I
like
think
that.
it's been called a mock ledger.
Mock ledger,
before.
yeah, good name.
Yeah, so it's just the ledger part, not the consensus part. It's perfect for simulating the ledger transitions if that's all you care about in your testing. In a particular test.
We call it ledger framework.
Ledger framework is the set of rules that we have, and we allow it to
It's super
change
set
it. Yeah, ledger mock or mock ledger is a good name. Yeah, we will think about changing it. Yep.
Yeah. So to get back on track, well, we have some some local in-memory thing that allows you to do two things. It allows you to throw the transactions in there and see whether they satisfy the ledger rules. Scalus, as like Alexei has just mentioned, a set of implemented ledger rules which repeat the thing that that a node does, and you can actually get the nice image by typing this query, which I've done multiple times at this point. Whoever's familiar with Cardano development has seen these words, many times, and we've implemented a substantial amount of them. And the goal is to have it match with whatever node is doing. Yeah. So already,
it's not the recent version. Now everything is green here. So
yeah, everything is green. We did not. Yeah, the only thing missing is I think it's something with Byron addresses, checks of Byron addresses. Yeah. We will make it as well, but a bit later. It's not.
So to sum up, we have all the rules that work with UTXOs, right, and scripts.
Yeah, and so in terms of correctness, checking against the local ledger view already gives you like a not really like a foolproof yet that your transaction is going to be good. However, it gives you like a good amount of confidence that whatever it is that you've built is at least not going to be straight up rejected by the real node. And also it maintains the set of UTXOs. So, any sort of test that you might run, whether it be like one transaction that, tries to do something with the strip locked funds, or perhaps like a series of transactions where you lock them, you try to unlock them, but you fail because the validator rejects the attempt, and then you finally are able to spend them, by satisfying the conditions that the validator tries to enforce. This can be done locally in a nice sequence using the provider, right? Because the transactions, they modified the ledger view state that we have in memory. And the best thing about this is that it runs roughly this fast, right? I mean, we're talking milliseconds here on like a fresh compilation. It's it's pretty fast, and it makes a transaction. It modifies the UTXO set. It checks all of the rules. And also, one of the important thing about the rules from the ledger framework is that you can use them when building the transaction itself. I don't think we've mentioned it, or perhaps we did, but the ledger rules that I've just that I've explained that the node also does, they're represented in Scalus, and they are available for you if you want to check your transaction against one or several, or perhaps you want to make your own. There's an API, it's a whole library, it's pretty easy. So to just illustrate it really quickly, there's, this is basically how it looks like. Fees, okay, validator checks, it corresponds to something from the Haskell implementation. There's a whole bunch of code that checks whether the fees are okay. Yes, but the more important thing is that it's a part of the validator library, and this is a thing that you can implement to check the invariance that your transactions might satisfy. Something that is not covered by the node that the basic Cardano node. Something specific to your protocol. You can also do it using the library, and you can also check them in memory together with the node. All of it, connects together.
Yeah, I'll give you a really good example of where this can be useful. So, for example, you'll see later on when we present Hydrozoa, part of what we need to do is we are trying to see how much can fit into a single transaction. So imagine you start off with like a base case, and you want to add an input, add an output, you keep adding them until you see that you've met the limits, and then you should stop, right? Because you need to leave the rest for a subsequent transaction. Well, to do that, you can actually invoke the transaction size validator, just that one individually, right? Every time you add something, and see until it stops passing, and then you just roll back to what you had right before that, right? And so you can choose. Scalus gives you the flexibility of which ledger rules you can invoke at which time, and sometimes it's convenient to invoke a smaller set of them during the transaction building process, as opposed to only at the very end when you're about to submit the transaction, right? Because ultimately, while you still need to satisfy all of the ledger rules if you're submitting to mainnet or something, right? You can choose strategically when to do it.
Yeah, just a quick mention that this code is cross-compiled to JavaScript as well, so potentially it can be used from JavaScript libraries and code from browser, essentially, if you need it.
And the idea behind using our ledger rules implementations in development is to satisfy our mission and goal of our Scalus development platform. We're fighting to make the development experience as pleasant as possible, but also would like to accelerate the development. So reducing the your TDD cycle to really milliseconds is something that is, I think, quite valuable for especially Cardano developers.
Yeah.
I'll let Sergey continue, and then we'll collect all the questions all together, and we'll have a discussion.
Yes, thank you, Lexi. And as you can see, I mean, this reads like English to me, at least. Like this reads like what you would expect from a transaction test. Like you make a transaction to lock something, you submit it, then you find the locked UTXO, then you try to use it to unlock it, and all of it actually invokes ledger rules, modifies the ledger view, and actually lets you enforce invariance on your stuff and use it for testing locally and really fast, which is pretty nice. As a sort of a next step for your testing, what you can also do is, except for testing locally and running those kinds of tests, is to submit it to a network, right? You have a choice of them. You, of course, can just do preprod or preview. It's going to slow you down a little bit because transactions kind of take, seconds to reach, whereas this is like milliseconds or even tens of seconds. The next step that you can do while, losing speed but gaining completeness is what we are actively using is Yaci devkit, which basically, for those unfamiliar, I'm pretty sure launches like a local mini network with a node, and it like launches this fast, right? I mean, it's ready to go. Has a lot of library code written around it. You can, pack it into Docker. It's pretty compact. You can run it on your CI because, I mean, well, this is like a process, but still, for integration testing, I feel like it's a very good trade-off between completeness, speed, and how safe you are. Also spits out a bunch of UTXOs for you to play around with. Really nice. You can kill it, you can relaunch it, and you can send Scalus transactions to it. This has a Blockfrost compatible API, which we have a small wrapper around, and you can, when you're done building your transaction, you can submit it right onto the Yaci devkit. This is done for now using this thing, which implements the familiar provider, which basically uses Blockfrost to query UTXOs and submits things. This is a bunch of really trivial code, but yeah. Find UTXO, submit a transaction, and get a result that see what it does basically. And Scalus can do it. This is yeah, we're here. This is still testing the HTLC validator. So we can go through this through these tests. This basically looks like this, right? In the following minutes, we're going to try to lock some funds behind the contract and unlock them on the local Yaci devkit running here and the preprod network running everywhere. This is going to take a bit longer, but yeah, all of this looks very similar because both of these things use Blockfrost. And to lock the test on the somewhat real network, you still, once again, if you squint hard enough, you still do like really predictable, and you do what you would expect you would do. You set up the addresses, make sure that you can spend the UTXOs that you want to lock. You pack it up such that you can later build a transaction with it, and then you submit it and see whether it has worked. All of this is available in our repo. You can read it. And yeah, so just to show you that it indeed works, we can launch it. Once again, it's pretty fast. I mean, it was 2.5 seconds, which is pretty fast. We have a transaction here that locked some of this guy's funds behind the HTLC. We can make sure that they're locked, but first let's make sure that this is indeed locked. You use this has this really nice swag around it, just perfect for local development. You can do this because this is the address. This is not the address that I'm sorry, Matthew. We have indeed spent some amount of ADA from here because it starts with 10 or 100,000 with a round number basically, and then we can take them back once again locally. Another 2.5 seconds has passed, and if we query it again, I mean without the fees, but it has indeed returned. And as you can see, this test contains like a very limited amount of code, and a bunch of it is reused between local Yaci instance and the whatever is going to run on preprod in a second. Once again, we can do this, assembling the transaction with Scalus, and in a couple of seconds, it's going to actually a comparable time to the mainnet. The caveat being that it will probably take a minute to appear here. No, it's here. Yes, as you can see, this has locked 11 ADA, just as our test says that it should. Let's pay the fee. Ledger loves this transaction, or at least, it's gonna love it in a minute. And just like the reveal transaction has worked on the local Yaci instance, it's gonna eventually work on the preprod. I'm pretty sure if I launch it now, it's gonna say that I don't have the funds to spend. No, it's not gonna say it. It's gonna create another transaction. Yeah, I mean, it's gonna appear here eventually. And just like that, with with some 200 lines of Scala, most of it being dancing around setting up local UTXOs, which we are going to work on the ergonomics. But yeah, you have your preprod transactions. They launch the scripts. They select UTXOs, and works whatever Blockfrost works. There it is.
Let's jump to questions. I wanted just to say one thing is. When you're working with Scalus Ledger rules implementation, you can also set it up in your CI. So if you have a bunch of tests, you don't really need to have a full node, which you don't need to run, for example, Yaci or something in your pipelines. You can explore and use the Ledger framework to actually validate your transactions, and so it will be extremely fast and useful. I'll put 10 minutes For the conversation, there is a question from Matthew. Can you elaborate?
Yeah, it was a bit backward because it wasn't really related to this segment. I think maybe more related to the previous segment. I don't know, maybe in between. Basically, you have validation rules that check that the transaction is correct according to some of the rules from the ledger. I was wondering if you also have what I call dummy rules. Like, obviously, these are rules that are not correct according to the ledger. I mean, these are also subset of, I mean, what I mean is that these are rules that it helps the person building the transaction knowing what is going wrong. So the example I gave is, for example, when you are using a redeemer and you need to present a witness for the script, like you can present it in the witness sept, or you can present a reference UTXO, like making sure when you do those things, for example, that the person building the transaction presenting the correct UTXO, and if it wasn't the correct UTXO with the script in it, like have a clear error messages and not just a random validation of the ledger rules that says something is missing and you don't know why, or something like that. Yeah.
We're trying to give decent errors in validation in validation, but I'm not sure how it would.
I think Ilya has the answer. This is specific to the transaction builder, and I think we do take care of it in the transaction builder.
Yes, exactly. So transaction builder, one of its function is to check that all parts corresponds to each other, right? So if you try to provide a reference UTXO that contains another script, you will know it at the stage of building the transaction. So
yeah, so this is the power of the fact that all the steps in the transaction builder need to contain things that are fully resolved, right? Means that the way it would work in practice is, let's say you want to have you want to spend one input that references that uses a script that references a script that comes from another reference input in the transaction, right? Typically, like the way you would have to do it is in the transaction builder, you would add the step to add the reference script first, right? So that it's available, and so we can check that it exists. And then you add the step like that says that I want to use the script that is referenced from. Like it should. You mentioned it by hash, right? And then we just check, have we already added a reference script input in the context before that contains the script for this hash, right? So it kind of takes care of it automatically. And if you haven't, then you'll just get an error saying that, hey, we couldn't find the script for the script hash, right, in the context.
Right, but that can be used to validate an existing transaction. And Matthew's question was more about probably the existing transactions, right? So in validators, I think...
No, I think he's talking about transaction building, right? Yeah. During the transaction building process, essentially think of it as everything that you want to reference, like refer to, just have it at an earlier step, right? And if you do that, then the transaction builder will find it and will take care of it, right? And if it doesn't find it, it'll just tell you, I couldn't find the script hash because either you didn't include it in the witnesses, right, before, or you didn't include it as a reference input from which, the script should come out, right?
And we've seen, I think, between those two presentations, we have seen two ways of use the ledger rules in it. In the presentation done by Ilya, it's a part of transaction building process. So you can actually invoke them directly one by one, and you can as well tell them to Matthew that you can extend your rules, so you can write any rule that you want and you can include it into testing.
Exactly.
But what Sergey was presenting is that you can actually abstract from it and build your transaction and use the Cardano ledger to validate it locally. And what's how we want to develop it a bit later, since guys are working on Hydrozoa. In Hydrozoa, you have a little bit different ledger rule set. So we would later expand it so you can select which ledger you would like to use. You would like to use, for example, Cardano ledger, or if you want to use Hydrozoa ledger or Midgard ledger or whatever.
Yeah. So the idea is that we'll have this abstraction that allows you essentially to write your integration tests, scenarios of transactions, of sequences of transactions, and then test them against different environments. So you can write with a local ledger mock, you can write with a Yaci devkit, which has different protocol parameters for that Cardano node, like few seconds block, etc. Or you can run the same scenario, the same code, with just different config passed against the preprod or Hydrozoa, because Hydrozoa would have different protocol parameters as well. So
Yep.
the idea is, if you have a set of tests for your protocol, you can run it against different environments and not rewriting it.
Yeah.
We have a question to ask you, Sergey. You want to
Yes,
speak
it's
about
good that
it?
we're on the topic of correctness and checking the validity of things, because during the implementation of it and during playing around with our existing validators, we've stumbled upon a conundrum. The conundrum being that testing involves launching the validator to see if it passes or doesn't pass. For example, the validator is a program, and when checking the program for correctness, you would, of course, eventually want to check what happens if the timeout is not signed by it, right? Does it indeed throw a transaction? Does it indeed throw the error? So invoking the validator involves a transaction in this style of more like integration testing. Thus, we need to build a transaction that invokes the script and checks whether the failure has indeed occurred as expected. However, building a transaction that fails a script, at least in the naive kind of your first iteration of it, is actually impossible, because, well, it is possible, but in a naive implementation, it is not, because building a transaction involves launching the script at the very least, because you need the redeemers, right? You cannot know the budgets if you have not run the transaction. If you don't know the budgets, you cannot know the cost that it's going to take you, like the fees, whatever. Thus, we cannot build a transaction without that is going to fail. However, if we're testing, we definitely want to do it. So to work around, of course, there's several immediate workarounds that pop to mind, right? You might say that, well, if it's the script evaluation that kind of blocks you from getting an a priori known failing transaction, well, perhaps we can substitute the evaluator for something that gives out like mock redeemers or like a hard-coded set of redeemers. And this is something that we would like to hear your inputs on, because it feels like a good topic to discuss. How would you, if you were to use a library, what way would you expect for it to allow you to build the invalid transactions to test the negative cases, all the while kind of protecting you from not doing it unless that's exactly what you intend to do?
Yeah, because like the question is, so essentially we had a discussion inside. So you can check for errors during transaction building, right? So you invoke script, it fails, and you check that it fails during transaction building. But the counter argument is that no, you want to check that the node answers you with the failure. Even if it is a mock ledger, you need to build a transaction and pass it to a node. So that we didn't decide yet. So we wanted to get your input, your view on that topic. Yeah, George.
Yeah, Leon.
Ilya, go first.
Yeah, I think the easiest way, at least we used several times, is mutating. So we can build valid transactions that we can apply different ways of trying to change it, right? Probably, Peter, do you want to talk about attack vectors we used somewhere in our tests?
Peter might be doing some work actually during this. But yeah, I think mutation is probably the way to go. So you build the correct transaction and then you mutate it in a precise way to, to be wrong in the way that you want it to be wrong, to check that it won't pass the validation in the way that you want it, right?
But how do you mutate it? Because it's gonna fail when the scripts are run during balancing.
Well, it depends on which rule are you trying to test, right? You're trying to test that a particular rule is enforcing things properly, right?
In
So
the
first of all,
validator.
my question to you is, you're asking about Scalus, the team. You guys need a way to test whether your validators are, his mic isn't working. So Scalus team needs a way to see whether or not the ledger rules that you've implemented, they are properly discriminating against invalid transactions, i.e. if a transaction doesn't pass through Cardano nodes ledger rules, then it also won't pass through like Scalus ledger rules, right? The Scalus ledger rules are protecting the integrity properly, right? That's what you guys are asking, right?
Not exactly.
Or are you asking for dApp developers, they would whether they want to check that their own scripts are properly enforcing against invalid things passing through? The second one. Well, I think it kind of applies to both, right? I mean, I think Scalus could probably use more of this sort of negative testing, like sad path testing for a lot of the ledger rules that you've implemented, because I think, happy path is easy to test. You just, you scoop up an epoch or 2 or 5 of Cardano transactions, you pass them through the Scalus ledger rules, and you see whether or not, the Scalus ledger rules have passed them all through. Negative testing, you kind of have to do through mutation as well.
No, we're talking about
I think the approach is the same, right? They would need to mutate.
We're talking about testing the logic of a validator with the transaction. So in your validator, there is a requirements that should fail, right? And you want to test that this case is checked. So you're trying to build a transaction that's going to fail the execution of a script.
Okay. Well, I think it's mutation is still the way to go, right? So you take a transaction, you take a correct one that passed the scripts, right? And then you just modify whatever condition, like whatever part of the transaction you need to check whether it fails the script. And then you only just need to run the script validation part. You don't need to run the whole transaction validation, right? Because you know that you're only focusing on the script evaluation.
But will it not run the balancing and the script evaluation again?
No, I'm talking about just run the script evaluator. Right? You don't have to run the whole balancing again. If you're only concerned about your on-chain script passing or not, then that's all you need to run, right?
Yeah. Well, you might need to run the balancing anyways, because your script might require, like the way that the transaction's being built might require that tokens be in certain places, and that might only happen if you balance. So the way that I've done this in the past is just manually creating script contexts and feeding those in. So
yeah, that's why I said to start with a fully balanced, proper, valid transaction, and then you take that away, right?
Well,
I think that means you don't have to rebalance necessarily, right?
Absolutely, because if you
just rerun the script.
Well, it might be a better idea to start with a fully balanced transaction, extract the script context, and then mutate the script context.
Yeah.
That's a possibility. That's actually what we've done, and that's our current approach. So essentially, we built a transaction, extract the script context from it, and use it in tests. But our thinking was to actually try to test all the way through the transactions, because thinking is that script context gives you way more inputs that are possible. So script context in reality is much more constrained than you can generate.
Right.
So I don't think you should be modifying the script context directly. I think that, again, as I said, you build a valid transaction with the regular building process. You get to the very end, you have a balanced transaction, right? And then you use transaction lenses to go in and modify the pieces of the transaction that you want to make wrong. And then you extract the script context from the wrong transaction, and you only evaluate the script evaluator on that derived script context from the invalid transaction, and then you get the result that you want. right?
Yes,
but-
and you don't have to validate because imagine you're replacing a signature or you're ripping out an input or an output, right? Fees can still the same, right? It's okay. You don't have to validate the transaction.
Yeah, you don't have to evaluate
But-
everything else because the focus of your test is, does your phase 2 Pluto script prevent this from validating, right?
Mhm.
So, I
So
think it
essentially,
works.
you suggest to run scripts and see that so construct a script context from a transaction and check against it, rather than constructing a transaction and sending it to a whatever node is to get a failure.
Yeah. So it's always about what is your negative test targeting, right? If your negative test is targeting a phase 1 ledger rule, right, then you modify the
Yeah.
transaction directly with a lens, and then you run just that phase 1 ledger rule and see like did it fail, right? If your test is targeting a phase 2 ledger rule, right,
Mhm.
or is testing some component of a custom, Pluto script that someone is invoking within the phase 2 ledger rule, right? Then that's the only part that you need to run, right? But you always start with a fully balanced, correct transaction, and you mutate it towards whatever you want to be incorrect.
Okay.
All right. Thanks for the inputs. Let's move forward. So we're going into the area of very complex protocol testing scenarios. Let me share my screen, and I'll give the mic to George. I'll put as well the timer.
Thanks, Alexei. So yeah, we are working on Hydrozoa. Hydrozoa is a layer 2 state channel, kind of an evolution of Hydra that optimizes the way that you interact with the way that the L2 interacts with L1 to make it as convenient as possible. Because what we've noticed from a lot of use cases in Cardano that are trying to use Hydra is a lot of them need to constantly bring stuff into the Hydra head and take stuff out, right? It's not enough for them to just start off with everything they need from the beginning, rearrange everything in the L2, and then close down the L2 and bring stuff out. They need the incrementals. They need to bring stuff in and out incrementally. They need to be able to change the membership of the head. They need all these sorts of capabilities. So this is what we're trying to provide in Hydrozoa. The focus for today's session is on bringing stuff in and taking stuff out, right? And in particular, in the context of transaction building, right? Because that is the heart of Hydrozoa, right? You could think of it, or Hydrozoa's interaction with Cardano's L1. So let me give you a quick recap. I'll share my screen of conceptually, what does this look like for us? Can you see what I'm sharing? Right?
Yes.
So one of our most important transaction types is what we call a settlement transaction. So what it does is it takes a treasury UTXO. This treasury contains all of the funds that have been brought into the Hydrozoa head to date, right? So everything that we've absorbed minus everything that we've paid out already before. And we want to absorb some deposits into it, right? I bring some funds into the L2. As well, we want to pay out some UTXOs out of it, right? And in general, in the L2, there might be an unlimited number of payouts that have accumulated that we need to send out, right? Because we just allow users in the L2 to say that, hey, I want this L2 UTXO to come out on L1, right? And you can send as many of these requests in as you want in parallel from different users and so on. And it's now our responsibility, or the Hydrozoa head's responsibility, to make sure that they all come out in an efficient way on L1, right? So effectively what we need is a transaction that can pay out an unlimited number of outputs, right? And that can absorb some number of deposits. With deposits, it's not as critical that they be unlimited, because we can always have a subsequent settlement transaction absorb some more inputs, right? And deposit UTXOs, it's a little bit more, slower moving, right, in terms of like bringing stuff into the Hydrozoa head anyway, because you need to kind of make sure that they are settled on L1, i.e. that the UTXO will exist, and so on. Whereas with payouts, it's always important, I think, for any dApp, that it should be easy to take funds out, right? Because that's what gives users confidence that their funds won't get stuck when they need them, right? So effectively, what we need is a way to absorb some number of inputs, or as many as it can fit into a transaction, and pay out as many outputs as possible, which, given Cardano's constraints, means that a single transaction can't possibly fulfill this in all cases, right? In some cases, you might have too many payouts than what you can do in a single transaction, which is why we have this rollout mechanism. And so the idea is that we will absorb as many of the deposits as we can come in, right? We always have to spend the treasury and produce a treasury that has all the deposits added in and all the payouts deducted out, right? And so priority-wise, the most basic settlement transaction is one that spends a treasury, produces a treasury, and spends some deposit UTXOs, if any need to be spent. And then we try to fit as many payout UTXOs as possible. But if we can't fit them in, then we'll just have an aggregate payout, like a rollout UTXO that contains all the funds for the payouts that we still need to pay out. And this allows us to have a subsequent transaction, we call it a rollout transaction, which will spend the rollout UTXO, pay out some more of these payout UTXOs, and then put the remainder of the funds in another rollout UTXO, which can then be picked up by a subsequent rollout UTXO, which will pay out some more UTXOs and put the remainder into a rollout UTXO until the very last one, where there's no need for a rollout UTXO because you've already paid out all the remaining payouts. So if we zoom out a little bit, this is what this transaction sequence would look like, right? You have the treasury comes in, you have the deposits are coming into the settlement, right? And then we have some direct payouts coming out of the settlement. We have the rest being put into a rollout UTXO to be picked up by this subsequent rollout transaction and all of its siblings or all of its descendants, right? And then we have a treasury output that gets created so that it can then be used by a future settlement transaction that will also absorb some deposits and have its own chain of rollouts, right? So effectively, we need a chain of one settlement transaction plus 0 or more of these rollouts, right? And now notice the difference. The very last rollout is different from any of the intermediary rollouts because it doesn't have this output of a rollout UTXO, this green, right? So effectively, in this sequence, we have 3 transaction types. We have the settlement transaction, we have the last rollout, and then we have all the intermediate rollouts, right? So that's kind of the conceptual diagram that I want you to keep in mind as we are taking a look at the code. So let me now switch over to my IDE. So IDE, can you see this?
Yep.
Yeah. Okay, great. So correspondingly, our settlement transaction sequence has 2 variants. One, where it's just a singleton settlement transaction, right? No rollouts required because everything that we needed fit into that one transaction. So no problem. And then the second variant is that we have a settlement transaction, and then we have some rollout transaction sequence that follows it, right? And so we need a way to build this. So as you can see, the overall process looks pretty straightforward because we have nice building blocks, right? So if we zoom out to just the sequence view, then we get some arguments. What are the arguments? Well, this is specific to Hydrozoa. Every time we have a new settlement, we need to bump up a major version, like it's a block. It's a major version of an L2 block, right? And we keep track of that in the data. We have some, we identify which treasury UTXO we are spending in this settlement transaction. This is where all the existing funds are coming from. We have some list or a vector of deposit UTXOs that we want to attempt to spend. And then we have some payout obligations generated by that have been generated by the L2 that we need to meet. We need to pay them out on L1, right? So the end result will be that the settlement transaction sequence will pay out all of these payouts, right? All of them will be fulfilled. And then as many of these as can fit into the settlement transaction will be fulfilled, and the rest will be left for later, right? For a subsequent block to handle, right? And so the way we go through this is first we check, do we have any actual payout obligations in this particular, like in these arguments? If it's empty, then we know that we'll just have a singleton transaction, right? Because we'll just have the settlement transaction. There's no need for any rollouts because there's no payouts, right? So that's the easiest kind of case. If we do have some payouts to handle, then the way we actually do this is we build the rollout transactions first. But obviously, the rollout transaction sequence depends on the settlement transaction because the first rollout UTXO comes out of the settlement. So in fact, these aren't full transactions, these are partial transactions. These are continuations, so to speak, right? That are almost full transactions. The only thing that they're missing is that initial rollout UTXO that's going to be the input of the first rollout transaction, which is then going to allow the first rollout transaction to be completed, which means that we'll then know what the input is coming out of it into the second rollout transaction and so on through the chain, right? So it's like a sequence of transactions that is sort of detached from the Cardano graph of transactions, right? And that can be attached by providing that rollout UTXO that came out of the settlement, right? So
well, why do we need to detach it? Why do we need to detach it? We need to compute.
Yes. The reason why we need to do this is because one of the things that I might have glossed over a little bit in the diagram, right, is that so if I go back to the diagram, this is not an abstraction. These are actually the inputs that are coming in and out, right? So normally when you see diagrams like this, it's sort of assumed that, oh, there might be some change output or there might be some additional output that is used to pay for fees. We can't do that here. These are the fees must actually come out from these inputs, right? Which means that the settlement transaction needs to put into this first rollout UTXO, it needs to put in not just the funds that are required for the payouts, but also the funds that are required for this transaction fee, and this transaction fee, which means that the settlement transaction can't be completed until we know what the fees will be for these rollouts, right? Which is why we need to build out this sequence first to find out what the fees are for this sequence, so that then we know in the settlement transaction what we need to put into here, right? And then we can provide this to all of this sequence to complete it, right? So that's the kind of tricky part, right?
Yeah, that's cool. We need a slogan, something like "impossible on Ethereum" or something.
Yeah,
like
it's like not time, but with transaction sequences, essentially. So yeah. So anyway, getting back to my IDE, so we've gone in, we built the rollout transaction sequence, right? Now we can actually build the settlement transaction, right? So we're going to feed it as part of its arguments. We're going to provide it with this partial sequence of rollout transactions, or this sequence of partial rollout transactions, because it's going to need that information to be able to know what sort of rollout output it needs to produce, right? So let me dive into the settlement TX in here real quick, right? And in particular, I want to show you, one sec. There's two builders for the settlement transaction. So I've already mentioned before, the simplified builder where there's no payouts, right? This one doesn't need to do a lot of work. The second builder where there are payouts, this is the one that will be provided with the the sequence of partial rollout transactions. And in here, one thing we try to do is we try to merge the first rollout transaction into the settlement transaction, right? Because if it's possible, then there's no need, there's no need for a separate rollout transaction, right? Because the way that we actually built out our rollout transaction sequence is we kind of first assume the most pessimistic case. So assume that no direct payouts are possible to fit into a settlement transaction, so that all of the payouts are handled by the rollout transactions. And since we're building it backwards, we are building the rollout transaction backwards because the last rollout transaction is the one that does not need to produce a rollout output, which means that it doesn't need to account for any subsequent fees. So we can actually build it almost fully. The only thing it's missing is that input, right? And then we work our way backwards, which means that since in each rollout transaction, we pack as many outputs as possible, and we only create a predecessor rollout transaction for it if there are any payouts remaining to still pay out, right? That means that in a particular rollout transaction sequence, the last rollout transaction will be completely full if it has any predecessors, right? And only the first rollout transaction might be like fairly small, like might not be entirely full, which means that it's a good candidate to try to merge it into a settlement transaction to save on that TX fee, right? Because if you can combine the first rollout transaction with the settlement transaction together, then you can save the fee for that first rollout transaction, right? You never needed to pay it because it could fit into the settlement. So we attempt to do this. If it works, then we essentially eliminate that first rollout transaction. If it doesn't work, then no problem. We'll just keep it, and we'll have all of the payouts be handled by the rollout transaction sequence. So this is the main difference here for the settlement transaction, right?
And you handle this with the ledger rules, right?
Yeah. So we have so in here in this try merge first rollout, I take this this sequence, right? I extract the first transaction, the first rollout transaction. I take its outputs, right? And I try to attach them. So I extract the outputs from the first rollout transaction. I have an optimistic trial, right? So this is like, what if I try to just add replace the settlement transactions rollout output with all of the outputs of the first rollout transaction. I glue them together in a sense, right? So I do this, and then I try to finalize the context. And if this fails, then I know the optimistic trial failed, which means I use the pessimistic backup scenario where I didn't merge them, right? And so in here, I select which one passed, right? And then I have the merge result, and yeah, so that's basically what I do. And so ultimately, what gets returned out of this, the result type is, if there are rollouts, right, then I will have the rollout transaction sequence partial, right? And notice in here, this will be either the original sequence of partial rollout transactions, or it will be the same, like the tail of it, i.e. with the first rollout transaction skipped, because we succeeded in merging, right? So that's kind of what I return back. And as well, in the result of the settlement transaction building process, I also indicate which deposits that I succeed in fitting into the settlement transaction and which are left over for later, right, to be handled by a subsequent rollout settlement transaction sequence building, whatever, or in a separate L2 block, essentially, right, major L2 block. So I get this result out, I case match on it just to repackage it into this settlement TX-SIC result, right, which was just going to have the settlement transaction sequence, which includes the settlement transactions as first element, and then all of the rollout transactions, plus is going to indicate, okay, these are the deposits that the settlement transaction was able to process, and these are the deposits that are deferred for later, right? So yeah. And one of the nice things as well that we have in here is that our pipes ensure that by construction, it's impossible to have a settlement transaction that produces a rollout output, but no actual rollout transactions that spend that output, right? By construction, it's impossible for us to have, things that go into nowhere or things that are trying to spend something that doesn't exist, right? Because our pipes ensure this, right? Within our settlement transaction sequence type, you'll see that the no rollouts version of a settlement transaction sequence will have a no rollouts version of the settlement transaction, right? Which means that this settlement transaction definitely doesn't have a rollout output, right? By construction. Similarly, the settlement transaction sequence will only have a settlement transaction that does have a rollout output in it. And it will also contain a rollout transaction sequence that depends on it, right? So we've eliminated those types of bugs where things are kind of not coherent in this way, right? And we don't need to check things with like, does this exist? Does this not exist? As soon as you get, this constructor, you know that everything inside of it meets those invariants, right? So it's very nice in this way. And furthermore, in our settlement transaction type, right, we are actually using row types, and we are using not, sort of dumb UTXOs of, oh, this is just a Babbage transaction output or something. These are domain-specific, our domain-specific definitions of those UTXOs. Like a treasury UTXO means something special for Hydrozoa. And we want to make sure that every transaction that spends it is using the same definition. Every transaction that produces it uses the same definition. And furthermore, every transaction that spends a treasury is spending it and uses the same field name so that you can always access it in this way, right? So everything is structured, everything is domain specific, which means that we can talk in terms of our business logic as opposed to talking about low-level Cardano transaction building concepts, right? So that's one of the very nice things that we can do here. So yeah, overall, this works. Let me show maybe, here's our test generator for a settlement transaction sequence. So we're using this sized generator. So the size is controlled by the property testing framework, Scalus or something. And we're, we have a generator that either just creates an empty vector or creates that size, a vector of that size, or that size times 5 or whatever, right? We take the first 1,000. So potentially this might be like up to 1,000 deposits or 1,000 payouts or something like that, right? This is just a little helper. So to create the transaction, we generate the head peers, we generate the multi-sig address for the head based on those peers. We generate some major version that's assumed, right? And then we generate, I guess, 0 to 1,000 deposits to try to attempt to absorb them in. We generate, I guess, 0 to 1,000 of these payouts, right? And then we create the actual transaction sequence, right, with this. And so, yeah, this works. And in this case, I'm going to run this test. I think it takes about 20 seconds because right now we're not doing things very efficiently. We're being extra paranoid about correctness because in our current code for building the settlement transactions, every time we add an input or we add an output, we are actually validating the entire ledger rules and we are script evaluation, transaction balancing, everything. We could actually be doing things more efficiently because, as I mentioned before, when you're just building up a transaction by adding inputs and adding outputs, the only thing you really need to evaluate is the transaction size rule, because all you care about is, does it fit into the transaction? So we haven't incorporated that optimization yet into our code base, but I imagine as soon as we do, it's going to speed this up because we won't have to, reevaluate everything at every input. We'll just have to do it at the end whenever you build a transaction. So
also this for all generates like 500 tests or something like that. So it's not the one test that takes 20 seconds. It's like it runs.
Oh yeah, right. So this is right. So yeah, so it's like 500 tests times 100, or is it just 500?
Depends on your config. I don't. What do you use? Mean successful. Yeah, I think by default it's 500. So it's gonna generate random distributions of those rollouts, construct all those thousands of transactions, and it runs it for 500 times basically. So it's not tests that takes 20 seconds. It's actually a huge number of transactions being constructed there.
Yeah, absolutely. And there's a question about fees.
Just finish. Let's see. See if you need a couple of minutes to finish the demonstration, and then we'll.
No, I'm done. I'm done.
Oh,
so
cool.
I'm just going to summarize overall. So what have we achieved with this? We've essentially achieved a transaction builder that can have essentially an unlimited number of outputs, right? And it'll just automatically, under the hood, split it up into a sequence of transactions, right? Which is actually quite awesome, I think, right? You can almost think of it as like, I just have a transaction that creates an unlimited number of outputs, and under the hood, it might be several transactions that they might need to be signed separately or something. But it's no big deal. Like we've eliminated essentially the constraint that Cardano has on transaction size in some sense.
That's very awesome. I think we need to make it as a design pattern or like a standard library solution for this sort of. It's a protocol level solution for this problem. Many protocols have.
Absolutely, yeah. And so one of the things I haven't shown today, but maybe I'll show in a future session, is, for example, The settlement transactions that I talked about were ones where you spend a treasury and you recreate a treasury because you want the head to keep going. But obviously, at some point, the head needs to stop. So for that, we have a special, you can think of it as like a special flavor of a settlement transaction that spends the entire treasury, doesn't produce it, pays out everything, right? And it's kind of the last transaction, so to speak, of the head, right? So in fact, in our code base, what we do is we generate a settlement transaction that does this, and then we upgrade the settlement transaction into a finalization transaction, and that gives us a finalization transaction sequence. Because the raw transactions themselves don't need to change, right? It's just the settlement transaction that needs to be upgraded. And so we achieve this using this modify method within the transaction builder, because we're essentially just adding a few extra steps, and we are modifying, I guess, the data of the treasury output, and then we have an additional transaction that comes out of it to deinitialize the last remaining portion of the settlement. Anyway, details.
Impressive.
But the point is, just upgrade the first transaction in the sequence into some other specialized form of it after the fact. Why not?
Yeah.
So
we went from basics into super advanced use of scenarios on L2. I'll put 7 minutes. There were 2 questions. Let's see if there is any other. Matthew, you asked a quick question. Do you want to elaborate?
Yeah, my question was about the size constraints. Obviously, you can only do this as long as you are able to have at least 4 things, like 2 inputs, 2 outputs. Do you have to have a whitelist of assets that can go in and out of the head or something like that to protect against such kind of attacks?
you're talking about if the treasury grows too big?
Yeah.
Well, actually, the nice thing about that is it can't, by construction, it can't, because in order to bring stuff into the treasury, you need to have a transaction that spends the treasury and produces that treasury, and also has the inputs that contain the assets that you're putting into the treasury. So if the treasury that you produce can't fit into that minimal transaction, right, then that you won't have the problem downstream, right? Because you need to create that treasury in the first place, and the transaction to create that treasury is the one that brings the funds in, right? And that already is the base case, right?
Okay.
Does that make sense?
Yeah, kind of. Yeah. Okay.
So I think in almost all cases the treasury is prevented from growing too big, so big that you can no longer withdraw anything out of it, right? But yes, we have a follow-up project in Hydrozoa that just got funded with Catalyst, where we're going to focus particular attention on reliability and performance. And so we're actually going to have tests and invariants that enforce this more concretely than this intuitionist intuition that I gave you just now. But yeah,
When application
we are aware of this. What's that?
when application on mainnet.
We're actually looking right now. We're discussing with George, and we're looking right now for the projects and products who would like to really use it, and we would like to start onboarding and piloting with them while we're building all other capabilities, interfaces, and stuff. So right now, and I think during the Cardano summit, we'll spend some time speaking with the businesses or products or projects who would really need this type of system, to see who would be the first adopters. And
yeah, absolutely. I mean, we already have some people that want to partner up with us for a pilot project, and we're thinking of onboarding them fairly soon. So if you want to be among that group, then let's chat. I think, Mathieu, you'll be at Cardano Summit next week, right?
Oh no!
Oh, it's unfortunate.
Sorry.
But you're next door, aren't you? Are you in Switzerland or France or?
Germany is quite far away, right? And the summit was expensive also, so yeah.
Oh, come on.
I'm not paid by the CF to go there, so yeah.
Yeah, fair enough.
Okay.
Well, okay. In any case, we can continue chatting about it, and yeah. So I think pilot projects are going to be coming to Hydrozoa fairly soon.
Okay, thanks.
And like the idea, maybe one thing to say is that once we have somebody who is seriously considering starting with Hydrozoa, I think that will lead to some kind of conversation how to speed up the capabilities that are necessary for this business to actually roll out with Hydrozoa. So we probably will focus on those first. But this is once we have those businesses, we'll sort them based on the reality of their project and the intention level. All right. Do we have any other questions about
Yeah,
presented?
I wanted to answer actually the question from Fabio regarding the fees. He asked, can the fees change from epoch to epoch or slot to slot? And the fees are dependent on protocol parameters, and protocol parameters can be changed only on epoch boundaries. But in order for protocol parameters to change since January of this year, this change requires a governance action and voting procedure and info action first. So you'll be like months ahead of any potential protocol parameter change that would change the fees. So that gives a lot of time to prepare, but essentially, another thing is increasing fees will break a lot of things. So I don't really think it's going to happen anytime soon. And even if it happens, we could just relaunch the head with new parameters in mind, basically.
Yeah. So I want to also say that the particular parameters that we are dependent on here are just the very basic fee parameters. Cardano has a fixed cost per transaction, right, of 0.155 something ADA, right? And it has a 44 Lovelace per byte fee, per transaction byte fee, right? Those have been stable for 7 years, and those are highly, highly unlikely to change, or they're highly, highly unlikely to increase. They might decrease, which will only be better, right, for fees, right? But those are the only things that that Hydrozoa transactions depend on, because they don't involve any CUDA scripts, right? They're just simple transactions with multi-signatures. That's it, right? So in that sense, essentially, every dApp on Cardano will break before Hydrozoa breaks if these fees change, right? So, and even if it does break, right? Even if our particular rollout transaction becomes invalid, the funds aren't lost. They're still held under the multi-sig address of the peers. So if it happens, the peers can just get together and say that, hey, let's just manually sign a transaction that sends the funds out the way we wanted it to be sent out, right?
Yeah,
it can be handled. They're not stuck in some script address forever, right?
So, exactly. You can change algorithm and pay out differently, and that's it.
Yeah, adding on top of what Alex said, that there is a governance action to be voted by dApps, but also they have this policy, I think, that they need to socialize it for 3 months before it actually could be applicable on mainnet. So this period is required for everybody, for all the applications and stuff to make the changes, necessary changes. So that's more than enough to update the head. All right. Yeah. I want to wrap up if you don't have anything to say on top.
Actually, I want to add one more thing.
Yeah. Okay.
About this question. Because of this long lead up of protocol parameter changes, I imagine Hydrozoa team will be aware that these changes are coming. So with a simple update of the Hydrozoa software, like we could create an update of the Hydrozoa software, which will just update the way that these transactions are being built, right? And the point of the settlement and rollout transactions is that they are built and submitted immediately to the L1. There's no need to sit on them for a while without submitting them, right? So it means that if you keep your Hydrozoa software updated, right, it'll just create the right transactions for the right protocol parameters on L1 as needed. And perhaps I think this is actually a good feature to think about, is similar to how right now Cardano node, it has multiple versions of its ledger rules, and it activates whichever one is currently the one that is is active on mainnet. So for example, even before the hard fork happens, all of the Cardano nodes are capable of working under the conditions of the hard fork version, right? It's just that it's not enabled yet. It's waiting for the signal from L1 to see that the hard fork is passed. So I imagine that the Hydrozoa node could work in a very similar way, where we could anticipate that certain changes are coming to L1, which might affect some of the constraints of Hydrozoa's L1 transaction building logic and stuff, right? And as soon as we detect that this hard fork has occurred or is about to occur or something, we could activate, that next version of transaction building. So we could be robust against this even more so, right?
Yes.
So
exactly.
yeah.
All right. The last thing to say. So first of all, thank you for joining today. It's a long session. We would be continue working on Scalus. So in our roadmap, we are going to expand on what we have built and incorporate the feedbacks that you guys provided. So we'll be working on providers, high-level API, maturing interfaces, refactoring some insights. Also, we plan to finalize our work on conformance testing for ledger rules. We'll be present on Cardano Summit in Berlin, so come speak with us. And for the next session, we are planning to host it in a month. We want to know from you what topics you would like to cover. So if you have any feedbacks or ideas or requests, do not hesitate to ping us in Discord, in Twitter, or speak to us in person. In our pipeline, we have multi-platform capabilities. Alex today mentioned that we effectively export many capabilities to JavaScript. We have TypeScript bindings, we have script evaluation, we have cost calculation available already in JavaScript with one function. So probably we'll showcase this. Also, we have very cool stuff that Hydrozoa team has built around coins management and like part of standard library, I would say, that simplifies drastically the work with multi-coins and coins. So yeah, happy to hear your ideas, requests, and we will follow on the roadmap and progressively showcase what we are doing. And yeah, tell us your feedback. Tell your friends about Scalus Club. If you can help us advertise it and bring more people with various views and stuff into the club. I think it's enriching for all of us. Yeah, probably that's it. Thank you for joining. And see you next time.
Thank you, guys.
Thank you for inviting us.
Thanks, guys.
Yeah, bye.
Cheers.
Yes, bye.